Okay, students, this video is on Algebra 2 Unit 1, lesson number 8, the nth term. So the goal of the lesson is let's see how to find terms of sequence directly, and also how can we write two different equations that represent the same sequence. So the student's task is given here 8.1. Among the four Among the four expressions that you see, the question is which among these is does not belong, or maybe which one is the odd one. Now, if you see the first one, this is the one that has only addition plus 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 plus. See, this is the only expression that has a only addition. So this expression has only addition. If you see the second one, you have both plus and both products. That means addition and multiplication. Okay, so very easy to identify. This is the one that has a exponential, one of the monomials. I call them as monomials. See, 5 is separate and the other one is 2 raised to 6. This is exponential monomial. You say exponential monomial. So exponential because the 2 is the base and the top, this one raised to the power 6 is the exponent. Anyway, so this one has both. And the last one is, this is the only expression that has repeated multiplication. Otherwise, also it's the same thing. If you see this expression, there are 1, 2, 3, 4, 5, 6. So 2 is multiplied itself 6 times. You can say it's the same thing. And these two are same is because this means it is 5 plus, and this 2 is repeated 1, 2, 3, 4, 5, 6. So it's like 6 times 2. Then if you check the 8.2, there is a 8 by 10 paper. So Claire takes a piece of paper with the length of 8 by 10. So that means this is 8 and 10 paper. Then and cuts it into half. The first part is cuts into half. Then she cuts it half again and again. So instead of writing a recursive definition, so last time we had done the recursive definition. If you remember, when we try to cut this into half like this, and then again we cut that into another half like this, and then again cut this skinny one into another one. So we had written down. um, so this in the beginning it was the whole page, and then this was the whole area which was 80. Then this becomes 40, and this becomes 20, and then this becomes 10. So last time we have seen the area, okay, the after area after n number of cuts is equals, it was the previous area n minus 1, this means n minus 1, was multiplied by, if you make it into half. Okay? So that was the recursive definition. Because in the beginning, without cutting, it was 80. So this whole thing was 80. And after that, for n greater than 1, that means after 1 cut, 2 cut, 3 cut. So that's what we get. So I hope, so this was what we did last time. So main thing is the sequence we last time we wrote is, let me write it again. It was written as recursive. It means area from the previous remaining, and then you multiply by half, and n greater than 1 and 2. So I'll just write it this in case, and we will see now what's going on this time. they gave us some expression, and we want to know whether that expression is really means the same thing. So let's see. Let me make a table. So what I try to do is I've made two tables. You can see the first table here, where n is the step number, this is the area, and the recursive definition or formula that we used last time was so many. This two past 2 weeks we did this. It means in the beginning the area, that means the area in the zero step without any cut, the area was 80, and after that, so this is when n is 0. And then after that, at any time, we seen the area was a n minus 1, one step before the area in the previous step times multiply by, so multiply by half. See? And this is for n equal to 1 and also greater than 1. So this is what we did last, almost like a week we were working on. But this time we use another different approach. That means in the case, this one, so this means in the beginning, C here, C0. So class name start with C0. So the area is 80. So this is 80. Then what you do is, so in the beginning is 0. And after that, in the first step, this is 40. That means this one, so this is C of 0, which is there. And this is 40, which is C of 1. Correct? So that means it is it was 80. So 80, uh, so I'll use 80 as the main red color to show. So it is the 80. So where this 80 come from? So 80 is when the paper is not cut at all, the whole area, that's the 80, zero cut. So that means uh, this C1 you have to multiply by C1 multiplied by half. Okay? So that's what we get. So from here to here, 80 is 40 because you're multiplying half. The next one you're going to do is you're multiplying. Okay, so here I'll write you're multiplying half. But in the second time you multiply another half. See? So that means you're multiplying two half to the red color 80. So that means when I want you to write this, I don't have enough room there. Let me, instead of writing this, I'm going to write here. So C1 is 80 times one cut. See? Now C2, actually uh, it is 40, the previous one times half. Okay, so this was 40, but that 40 now I have to you have to multiply by. So this was from previous step 40, which was 80 times half, and then again one more half. So yeah, what I did, I took a fresh page. Okay, it's the same thing. I made a new table. So this means it is C of 0. That means in the beginning the area was 80. So nothing is being done. But the second time, what you do is this time you multiply by, because you are going to cut the area into two, right? So it is going to be half. So when you multiply, the number is 40. Okay, but how did we get this 40? It's half of. So because this is 1, so your C1, okay, this is when n is 1. So C1 is the 80. So it is the 80, and this 80 is multiplied by the green color half, this half. Okay, 1. And that way we get 40, because half of this is 40. Now, how do we find this? Is the next is you're going to multiply one more half, right? The last time we were saying multiply by half. So the C2, so because n is 2, the area now C2 is going to be like how we wrote the previous one, that is this 40. All right, again, this 40 is multiplied by half. Okay, but then But then this is same as, but how did we get 40? Look at this. This 40 is because of this 80 times the red 80. So the red 80 times times half. So this half, okay, because I'm replacing this 40 by this piece, okay? And then there is another half. And you can see this works out to be uh, 80 is what was in the beginning, and now you're having half, and that half is multiplied itself two times, and that's why I put raised to the power, raised to the power 2. I'm putting a 2 because of this 2. So your C2 is this expression. See, I want you to focus on that 2, the 2, when the step number is 2, when you make two cuts, maybe this 2, this 2 is the same as here. See? Now, so that means the answer of this is going to be 20, right? It is 20. So that 20 will be here. Now again you multiply half because you're going to cut it into one more. So you end up getting multiplied by half. Okay? So it means from 80 to find this, so this piece now I want to write down C of 3, which is a purple color 3. So how many times do we multiply that? Starts with 80, the red 80. In the beginning, the paper was 80, and now you're going to multiply the green halves that you see here 1, 2, and 3. So it means it is half, 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 and half. Okay. So your answer ends up to be, of course, we know it's as good as doing half of 20, which is 10. Already you know the answer. But how do we write in this form? Is it's like 80, the red 80, and you have to, the green half is multiplied itself 3 times. So you write half raised to 3. So this is the C of purple color. Let me use purple color 3. When it is 3, this is 3. I want you to see the trend that you see here. What I'm trying to do is when this was the first one. So if this was 1 here, if this is 1, this is 1, then it is like raised to 1. There's a single like this 1 here. If it is 2, it is 2. If it is 3, it is likewise. We can do the next one. Going to be again multiply half. So there will be, so basically it is half of the previous 10, which is 5. But if you start from 80, it's like this 5. Step number is 4. So your C4 equals. So again I write that 80 times. So the green one, half. How many halves? You can see 1, 2, 3, and 4. So you're going to multiply this half, 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 half 4 times, and you are writing down C of 4 is that red 80, and you're multiplying half how many times? Half raised to 4. And the goal is, can we write, go on doing this activity, and you will see you end up. So let me clean this whole thing. You got an idea here. I'm going to write this again and get a new page straight away. So what's going on here is, with this is your C0 was 80, okay? C1 was 80 times half, half raised to 1. C2, two cuts, it is 80, but you're making two cuts, so it is half raised to 2. If it is three cuts, it is 80 times half raised to 3. And if it is C of 4, this is what we saw. And now we can generalize and write down for at any nth step. This is 4. So if I put n, it means n could be 5 or 6 or 7 or 8. So that's why we say nth term. Nth term means at any time we can write it. In the beginning it is the 80. We have the 80, and that 80 you multiply the factor, which is the half in this case. I use the green color, remember. I put a half raised and then raised, if this is the purple end, so this becomes raised to n. And this is for all n is 0, 1, 2, and so on. So instead of saying n is 0, 1, 2, 3, we just say n is 0 and greater than, see, greater than equal to. So this inequality takes care of all this. So I hope question was, and when you write like this is called, so the thing is, what is this called, right? So when you write in this form, it is called explicit formula. So this is called explicit formula. It doesn't depend on the previous step, but it depends on the step number. So, or another way to say it, nth term. It's also called a nth term. Okay. So now let's see what is the other question they gave us, please. Go back to the question. So the question here is, what is the approximately area the paper after cuts? So the best thing is we'll have to do Desmos or use the calculator. Desmos.com, can you use the regular, or you can the year that I have, Inspire, or you can use TI-84. I'll use the simple calculator here, scientific calculator. In this case, you try to type in, okay? So it was 80 times. You can see there's a 80 here. You can see here it is 80 times. So multiply and put parenthesis. Let me pull this up. So open parenthesis and 1 divided by 2. Go right click and then go make an exponent by clicking right here. It goes up and put a 10. And there you go. You already gave the answer right here, 0.078125. So C of 10, 0.87125. That's it, you're done. And then there's another question is, okay, so this is the first question was this. Now we have one more question. Now there's another student by name Kiran. So Kiran takes a piece of paper with 8, same thing, this one, 8 by 10. But this time he cuts away 1 inch width, means at the bottom piece, that means if this is 5, these are like 10 pieces, like this, and you have like this. So he cuts off this piece, see? So when he cuts off this, so how much is this area is? That's 8, right? This is 8. This is 8, 8. So each of this piece is 8, 8, 8, 8 altogether. 80. This is 80, right? So when you cut off one of this, cuts away 1 inch of it, that means it decreases by 80. And you can see Kiran's name starts with K, so that's why we wrote KN. So this is the area remaining. So what is KN actually is area of Kiran's paper after N cuts. So when you cut, so in the beginning it was there's no cut here. But if you make one cut, that is right here. So what's going on is this whole thing is going to become, there will be only, there will be like this one. And at the bottom you'll have 4 pieces, see, but they're all together. So this will be 7 here. So that means you're cutting off from, in the beginning it was the 80, from 80 you cut off one this part, see? This is that 8 is taken off. So it means it is 8 multiplied by 1. Okay. So even though I could have written 80 equals 80 minus 8, but we can always write it as 80 means just to show that one cut is one cut. And the second time, we see the step 2 here is this also is taken off. So that means this is the first one, this is the second one, and that's why you see there are two pieces here. And because there are two eights are taken away, that means this is two pieces. Each one is 8. So 8 times 2. And 8 times 2 is 16. And from 80, you take away 16 and you get 64. And check that. So that's why this is 64. So the next step you're going to write is it is 80, but this time you're going to cut another cut like this, but this will be only 7 here. See? So this will be 7. This is 7. Uh, I made a mistake here. This one is 9, right? Because when you take one, there will be 9 pieces left. Now I take another piece. When this is taken off, this will be 8 pieces left. Okay. So this will be, even though it is 8, but then I'm going to cut off the bottom piece. So you're cutting off one. So this piece is taken off, one more piece is taken off, one more piece is taken off. So there will be 7 left here, right? It is basically 8, 8, 8, and 8. So you're taking off 3 of them. So it is 80 minus 8 times 3. And if you work this out, that will be 80 minus 24. Because this is 24 and 80 minus 24. If we take away here, this becomes 7, 10, 6. I get 56. So that's 56. Otherwise, also from here, from 64, you take away 8, it becomes 56, right? So this answer is 72, and 72 minus 8 is 64, and again, so each time you're taking away 64. And likewise, we can directly write here, this will be 80 minus 8. So you're going to do 4 of them. So 8 minus 8 times 4. See? And that will be, you can see this is going to be 58. You can check with the calculator. So what's going on here is each time. So what is the trend here is you're going to, so in the beginning it was 80, then it is 80 minus 8 times 2, okay, then it was, sorry, just a single 8 times 1, 8 times 1, then you have 8 times 2, there it is. Next one is 80 minus 8 times 3. Next one is 80 minus 8 times. And you see the trend? If it is 5, it is 80 minus 8 times 5. What about if it was n, then n term? So when it is n, so this, if it is n, it will be 80 minus 8 times n. See? That's how that explicit formula which I'm talking about. So this is another way to write explicit formula or the nth term. Sometimes they use, instead of saying explicit formula, they also use the word definition. So the goal is that Kiran, so that means Kn is, in the beginning, it was 80 in the paper, and then it goes on decreasing and goes down. So you are taking up area of 8, and then you multiply n. How many times you do that? And this is when n is equal to 0, starts with 0. So you put a 0, and then instead of writing 1, 2, 3, you just skip that and you just put greater than equal to 0, and then you're done. And let's see, another question they're asking us is, okay, Kiran says that the area after 6 cards is this. This is what? After 6 cards? Explain the term, where did this come from? That's because 80, this means it is minus 8, minus 8. This means you are going on cutting 6 times the bottom piece. See? It was 10 here. It was 10. See, this was 10. And you went on cutting 6 times. So you cut off 1, then you cut 2, then you cut 3, then you cut 4, then you cut 5, cut 6. So this is gone. See? So only 4 are left. And that's what is going to be, of course, 8 times 6 is 48. And you get, if you do this little calculation, you get 32. Okay. And that also is correct. This is 8 plus 8 plus 8 plus 8, 32, right? So I hope that makes sense. This already I wrote. Right. Oh, they're asking you, write not recursive. Oh, so we can write here recursive. I mean, so not recursive basically means explicit, the one that I already wrote. That is kn is. So in the beginning it is 80, and after that at any time kn is 80 minus 8 times n, and that's for n greater than equal to 1. This is greater than 1. That's because you already took care of n equals 0. That's why. So hope that helps. And then let's see if there is another question there. I also put. Did they ask any more? Oh, which is larger? So on your calculator, you have to do. Look at the question is, this is larger is K6 or this? Remember, Cn was 80, Claire, and this is the formula she used. Kiran got Kn equals, it was 80, and you go on multiplying by 8 times n. So all you do is just plug it in 6. So if I put 6 here and a 6 here, so you do a little calculation. 80 times half is 0.5 also. You can write like this, same thing. And here you write k of 6 is 80 minus 8 times 6. And this one is 8 times 6 is 48, 50. And this is 32. And here you'll have to do a little work. If you want to use the calculator, so we can do right here, take this off and put 6 there. See, you get 1.25. And you can also show they put this in the Desmos calculator, which I did here. See, this is the class. You put this equation, and then this is the second equation. And I did put x equals 6n, so I draw. So class is the area decreases in a linear form. It means every time. Let's see, this is 1. So class area is every time you go one cut, it goes area goes down by like that. So you do 2 cuts, it goes here. With 3 cuts, it goes here like that. So this is linear. Linear because you can see this like this. Kn is 80 minus 8x. But this one is exponential. Exponential. It doesn't go like that each time. It does not have the same rate of change. Here you have the same rate of change, which is d is minus 8, which is common difference. Every time it goes down by 8, like this, like that. Okay, so that's what. But the first one is this piece. It decreases, makes half. So if this is 80, then it becomes 40. Look, this is 40. And that's a beautiful understanding visually what. Okay, so this is 80, then becomes 40, then becomes 20, then becomes 10, and then 5, and 2, and 1. Okay, so which one is bigger? So this is bigger. So this become bigger. This is Kiran, and this is Claire. So Kiran's number is because after 6 cards it is 32. For Claire it is 1.25. So I hope I made sense. So this is 8.3. I think this is 8.3. Okay. So I think we did this in the class, but in case you forgot, let me just explain. This is called Sapiensky triangle. where by just looking at this, you want to know, like, now there are two students who are trying to write some equation. Andre, let me think of only Andre here. So Andre, he writes something like this. So let me write this piece. So this is what Andre writes. Sn equals for, so for n greater than equal to 0, like this. Okay, it means, this means for everyone 0. Starting step number is 2. It means I'll try to show two ways. Let's talk only about Andre, what he's talking about. He's starting with 0. Because stop, I'm gonna make a step number. See here itself, I'm gonna make kind of a step number. So this is like n, and this is a number of black. So what does Sn stand for? First of all, we should know what does Sn stand for. It basically means the number of black black triangles. Like in the beginning, you can see there's one black triangle. So this is the only one black triangle. So that means Andre starts with 0, and then the next one it says 1, and then 2, and then 3, and then 4. So Andre says the answer for the first one. Let's put the answer also. This is what Andre does. So he writes, okay, there's a one black triangle. Then he says in the step 2, say 1, 2, and 3. He says 3. In the step 2, it is 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9. And then if you count all this, there are 27. And you can see there is a trend. Andre notices there is a trend. Each time Andre thinks it is multiplied by 3 again. Clearly 3 times 1 is 3. Again, if you multiply 3 times 3 is 9. Again, you multiply 3 times 27, 9 is 27. Next one will be, well, if you multiply 3 again, you end up getting 81. Yes, like that. So what he does is he's saying how many threes are there. So what he wrote here is in the beginning. So this basically means s of 0, s0 actually is just a 1 here, which is 1. But even though he wrote this means it is 3 raised to 0. And we don't know any number raised to 0 is always 1. So that's correct. S of 1, if I put replace n is 1, of course you have 3 here, right? But if I use this formula, it is 3 raised to 1, which is 3. So it works, see? And likewise, so if I put S of 2 in the step 2 is the answer is 9. And let's see if I use like this, it means 3 raised to 2 because of this. And this means 3 times 3 is 9. And that's how you get. So basically, how many threes you are multiplying? So this Andre thinks, this is what Andre thinks. Andre uses this because he begins from 0. He sees, now let me make it 9. Let me take off everything and make it another way, easy way to understand this. Mm, okay, I'll make a vertical table. It means, watch this fun. So what Andre does is in the beginning he uses n, and then Andre, I think he is using Sn. Okay, Sn means number of black. Uh, so in the beginning there was 1, then 2, and this is what Andre thinks. The step, these are step number. So in the beginning there was 1, and then you had 3 black triangles. Then you had 9, 27, 81, and then 243. So the question is, how did he get the formula? So he's thinking, okay, he's thinking from here to here, you multiply 1, 3, right? So this is S of 1. So from 1 to he multiplies 1, 3. The next time what he does is he multiply another 3 here. So each triangle breaks into 3. So this answer is S of 2. But this time, 1 was the beginning. There was a single, this is the 1. And then now you are multiplying this 2 of this 1, 2, 3 times 3. So it is 3 square. So when you write this one, it means you're multiplying 1, 2, and 3. So there will be another one, each triangle breaks into another 3. So this piece is S of 3. So the S of 3 is, you have, in the beginning, it was 1, and to 1, you multiply the factor 3, and then raised to power 3. And likewise, you have Sn. If it is n, it is 1 times 3 raised to n. See, that's all it is, and that's called explicit formula. I hope it works. So it's just checking on. So the main is about explicit is about from the beginning. What is important is the beginning, whatever that is. Okay. And after that, you go checking on what factor multiplies like 3, how many of them. Well, the only important you should note down is this one starts with 0. Now, what does look at this? What does the other student Kiran? So what Kiran does is different. Okay, I'll use that same table. So Kiran starts with and this is a little confusing. Hopefully, I'm trying my level best to show. Okay, Kiran start with step number 1. So let me, you had that black triangle. He says it is 1, and then this one. See this one. He said this is step number 2. So he starts with 1. So when it is 1, it is 1. When it is 2, it is 3. See, if it is 3, like this. And you have 1, 2, 3, 4, 5, 6, 7, 8, 9. That's how you have, this is 3 and 9. And like that, you have 27. So the question is, Kiran, uh, how did he get 3 raised to n minus 1? Now this looks crazy, right? So that's because if I want, this is like when n is 2, this is when n is 1, this is when n is 3, this is when n. So let's write. Okay, it means from here to here, it means this step. Now this step is S of 1. S of 1 is the red one. This one. See this one. Yes, baby. So the second one is this one. This 3. S of 2. The step number is 2. And the answer is 3. But how did we get 3? It's because in the beginning it was 1. And to that one you multiply 3. Okay. You let me use different color 3. Okay. This is your single 3 or multiply. 3 raised to 1 means your single 3. So you multiply 1, 3. And can you see the step number was 2, this step was 2, but you're multiplying a 1, 3, single 3. Watch the fun. This is step number 3. So S of number of black triangles in the third step is, your answer is 9, but you remember you're multiplying how many threes? So you do 3 times 3, 9, and again multiply 3. So you're kind of having two threes multiply. Mm, so it is like in the beginning we add 1, and then you're multiplying by two threes, 1 and 2. So it is like 3 raised to 2. What's the fun? Black color. That means black. So this is 2. So you're multiplying 2. So if this is 3, this number is actually, this number is 3 minus 1. So if this is 3, it decreases by 1. Well, and suppose n is 4, you're going to multiply one more here, another 3, because 3 times 9 is 27. So if I put 4 here, the answer is 27, but it is because in the beginning you had 1, and then how many times do you multiply 3? And you can see you're going to multiply altogether 1, 2, and 3. So there are 3 raised to 3. Watch this. Now this is, if we compare here, it is 1 less. So likewise, we can write, let's see, if I want to write s of 5, this will be 1, then 3 raised to 1, 1 less. Oh, if I write 6, this will be 1 times 3 raised to 1 less, which is 5. So the question is, can we write from here in general the explicit formula? And you can see if I write s of n, this will be, in the beginning we have 1 because of this, and then you go on multiplying the green, okay? So, but then you are multiplying how many? You are multiplying 1 less. So if this is n, so this is n minus 1. And and here you say, okay, uh, n is greater. This time, because you start with n is step number 1, you write n is greater. What does this mean? 1, 2, 3, 4, like that. I hope I make sense. Okay, this completes that. So both are correct. So it's not that. So if you see this in this example, okay, so both Andre also is correct, and he is also correct. See how beautiful both are. So both of them are correct. Both of them are correct. It's just that Andre started with 0 like this, 0, 1, 2, 3, but uh, the lean, I think the lean, I said Kiran maybe, but the lean like that starts with, this one starts with 1, here 1. So he says 1, 2, 3, 4, like that. So it depends on, like, how do you start. If you start with 0, this is how you write. And if you start with 1, if you start with step number, that's the trick. If you start with the step number 1, you have to put raised to n minus. Okay, I think that's all I wanted to show. And I'm tired. I don't know. Let me see if there's anything else. Oh, are you ready for more? Yeah, there's one more question. Are you ready for more? And here is a geometric sequence. They give you 3, and there's a blank here. And there is the next one is 6, another blank, and the 12, and then blank, and 20. The question is what goes here, right? Now they give you 6 here. It's a geometric sequence. So there has to be multiply something here. I don't know what it is. I'll put R, and then again you multiply by same thing R. That means you can see from 3 to 6, you're multiplying 2 R's, 1 and 2. So that means that this 6, how did we get this 6? 6 is this R, you multiply. in the beginning it was 3, and then you're multiplying by 2r. See, r times r. So when you divide by 3, you'll get this as 2, and this means you're going to get 2 equals r square. And using the radicals, you can say, okay, r is square root of 2. See? Or you can also write as 2 raised to half. This is just if you are ready for more. If you don't understand, that's okay. Just wanted to be sure. And the final part is the cool down. There's one question here. The sequence is given like this. This is called explicit. This is what is shown. Explicit formula is given. But Diego, another student, he writes an equation for the n term in this form. He writes, so the question is he, if he's correct, if is he correct? Explain, how do you know? Now what I would do is I'll make a table to just make sense out of this. So this is n, this is f of n. So if you see this in the beginning, it starts with 0, 1, 2, 3, and 4. It is minus 3, and then what does this means in the previous step, one step before, whatever this, you are going on adding. So from here you are adding 0.5. So you are adding 0.5, and when you do this, it means it is minus 3 and plus 0.5 will be minus 2.5, and then again you decrease it by adding 0.5. That will make it minus 2. Then again decrease by, add 0.5. That will be minus 1.5. So this is how you get for the first one using the explicit formula. But the question is the other guy is correct? So if you see the next one, is this correct? What does this mean? It's the same thing. You have a table, see, N and F, and what is this means? N is 0, 1, 2. That's what it means. It means 0, 1, 2, and 3, and 4. And what this means is in the beginning it was minus 3. This is this is the beginning. It's like in the earlier problem we had 8 by 10, and it was area of the 80, right? Something like that. So, and then you go on. So this is how it looks difficult. It means you're adding 0.5 times n. Now, what is that n means? How many times are you going to do this? Okay, so it means first time is, if it is 1, so you are doing, it means if n is 1, you are adding 0.5. That's why you get minus 2.5, right? So you are adding 0.5. Now from here to here, you are adding another 0.5, you get minus 2. So it means you are adding 2 of this, see, 1 and 2. If you want to write next one, which is minus 1.5, so this basically means how many 0.5? So it's like 0.5 is added how many times? N times. So maybe if this was 1, you are adding only once. If this is 2, yeah, if this is 2, you are adding 1, 2. If this is 3, then you are adding 1, 2, and 3. That's what it means. Okay, so both are correct. So both are correct. Okay, so that's it. Good night. I'm tired. Thanks for watching.